Hello everyone, welcome back to Calculus BC. In this lesson, lesson 28, we're going to talk about Euler's method. And this is the third way that we can express a differential equation. So in previous videos, we talked about a differential equation and how to solve it. We've also looked at slope field, which is a graphical approach to differential equations. And now we're going to look at a different way of solving a differential equation by Euler's method. Now, I will tell you all right now that these are calculator questions. It is pretty tedious. I'm choosing an example that has a lot of work to it. Most of the time you do something that's much, much less than this, but I want you guys to get a good idea of what to do for Euler's method. This usually is going to be found in an FRQ. This is usually where it is. It gives you a differential equation. It has to give you a function. A differential equation. It has to give you an initial condition. And it also wants us to know our step size. So what we're doing here is we're given the initial condition that when x equals 0, y equals 1. So I personally have 5 columns. And we're going to do an example in the second video of this lesson where I'm going to just show you guys what I end up doing, because this table is not given to you. So the first 2 columns are going to be really easy. It's going to be your x and your y. And so we start at 0, start at x equals 0 and y equals 1, and we want to find y equals 1. All right, so we got to figure out what y equals 1 is. So this is where x equals 1. Our step size is 0.2. So I'm going to go ahead and add 0.2 until we get to our desired 1. So that's why we have these rows here. Normally, they're going to give you something like 0, and they're going to ask you to approximate y equals 0.4. You really only have to do this a couple times. This third column is going to be your dx. Your dx is your step size. So your step size is going to be what the dx is. So it's going to be 0.2, 0.2, 0.2, 0.2, 0.2. We won't have to do anything in this last row. And then we want to solve the differential equation. So this is what I put in my fourth column. It's just dy dx. So we can see that in this problem, dy dx is x over y squared. So I'm going to plug in 0 for x, and I'm going to plug in y for 1. Well, I'm going to get 0 for x, y for 1, and that's going to be 0 over 1 squared, which is going to give me 0. So 0 over 1 squared is going to give me 0. And let me go just do 0 over 1 squared is equal to 0. So you know what I did. Then my last column is what is dy? What's the change in y? Well, my change in y is going to be my dy dx times dx. So I'm going to take this column here and multiply it by this column here. So I tell students to multiply this column by this column because the dx's are going to cancel out. And so you're going to be left with dy. So xy dx, what is your value of your dy dx? And then you're going to multiply these together. So 0.2 times 0 is going to be 0. So my change in y is going to be 0. So what you have to do now is you want to do 1 plus 0. So our initial y plus 0. That value becomes our new y. All right, now once I do a couple more examples, then this is going to make more sense to you. Now we have x is 0.2, our y is still 1. So if we plug back into our differential equation, x now is going to be 0.2, and we're going to divide by 1 squared. So this is going to be 0.2. All right, so we're just simply plugging in here, and we're going to multiply 0.2 times 0.2. So we're multiplying our delta x by our dy dx, and we're going to get 0.04. And so what we want to do is we want to take the value that we have here, and we want to add to our y value. Because remember, this is our change in y. We're going to add now 0.04. So our answer is going to be 1.04. This number is going to be popped into right here. Okay? Let's do another one. So now we're going to have a new y and a new x. So here we're going to have 0.4 as our x, and now 1.04 squared as our y, because we're just plugging it in right here. And this is where we're going to get into our calculator, and our calculator is going to give us this value that's going to be 0.3698. All right. The reason I left it this way is because you usually want to go to at least 3 decimal places. And so if I were to, go to 3 decimal places, it'd be 0.370. And that's totally fine. There's no real right or wrong here. You don't want to, round to the nearest tenth, or usually to the nearest hundredth. You really want to go to the nearest thousands of 3 decimal places. And so what we're going to do now, guys, is we're going to multiply 0.2, our delta x, times our new dy dx, because this is going to give us what our dy is. And then we're going to get that this number is 0.0739. Now, we're going to add this number to our y. Remember, this is the change in y. So this is what our y is changing on this step. So we're going to add 1.04 to our function. And then that value that we're going to get now is 1.1139. And you're going to do the process over again, ladies and gentlemen. You're going to do the new x, which is 0.6. We're going to take our y, 1.1139. We're going to square it. And then we're going to get a new number, 0.4835. We're going to take this number here and we're going to multiply it by 0.2. We're always multiply by our dx. That's always going to be constant. And we're going to get 0.0967. And we're going to take that number and we're going to add to our y that we started with. Because again, this is our change. And by the way, if this is negative, we're subtracting it. All right. So it's just the sum of these two numbers. Whether they're both positive or they're both negative, you're still going to add them together. And so then we're going to get, and this next was 1.2107. And then, ladies and gentlemen, last step with what we're doing here, we're going to do 0.8 is our new x. We're going to take 1.2107. We're going to square it. We're going to get 0.5457. We're going to multiply that by delta x to give us our delta y. And this is going to end up being 0.10915. And then this answer, the answer to this problem is going to be this number plus our y. And when all is said and done, we're going to get an approximation of 1.3199. If we were to solve this differential equation, and we were to then use this initial condition to find our c, and then once we have that equation, we plug in 1, we're going to get this decimal answer. Okay, that's the idea of what's happening here. So this is another way of doing this where we don't have to solve this. Now, this is a very easy differential equation to solve for what's going on. And I encourage you guys to practice. Solve this differential equation. It's going to be y squared dy equals x dx. Solve it. Use the initial condition that y equals 0 equals 1. That's going to give you what your c value is. And then you're going to have a y function. And then go ahead and plug in. And 1 for x. And this is going to be the y you're going to get. Okay? Again, that was really tedious. Very tedious. Usually you only have to go to about here or here, but not as many as we do with this. But the more the step size, the smaller the step size, and the more that you do, the better the approximation is going to be. And hopefully that makes sense. So, if we look at this one. Oh, so this example 1b is to actually find the particular solution to our function and find y sub 1. So let me just do this. Because this video is not about solving differential equations, on one hand, just have the answer key up for you. And so we found our values here. So look at all this work that is done for everything. And I showed you guys every single step in the answer key that I've posted. And so if I solve this, I get, this function right here, y cubed over 3 equals x squared over 2 plus c. We use our initial condition to find that c is 1/3. We solve for y, and then we use our calculator to plug in when x is equal to 1. When x is equal to 1, which is what I did right here, we find out that y is approximately 1.357. Now, these are not exactly that close to each other, right? They're not. But it's because our step size was actually pretty big. Our step size was very big. It's like 0.2. If I had, done this and do 0.1 all the way up to 1, then we get a lot closer to our approximation. But at least you guys get the idea of what this is and how to solve Euler's method. Okay, so we're going to just finish up our video today looking at another example of what's going on. And this one, we can't solve the differential equation. right? We can't split this x minus y. So Euler's method's a good idea for this. So the first thing we do is I write our little table out, and in the next video I'm going to actually do the table. But this is the simple way of doing it. I always do x, y, I do dx here, I write dy dx here where we plug in our functions x and y, and then I multiply these two things together to give me my dy. So this is the idea of what we're going to do. We're going to always be given the differential equation. We're going to always be given our condition of x equals 3, y equals -2. So this is 3, this is -2. Our step size is 0.1, so that's going to be our dx. And so I want to know x equals 3.2. So if I do 3 plus 0.1, it's going to be 3.1. And if I do another plus 1, I get 0.2. So this is more likely the question that you would see on any exam, is what's going on here. So what we're going to do is we're going to find what dy dx is with x equaling 3 and y equaling -2. So I'm going to do 3 minus a -2. So let's go ahead. Actually, let me write that better for us. So 3 minus a -2 all over 2 times -2. So that's really poorly writing that, but that's going to be -5/4. Right? That's what we're going to do here, -5/4. We're going to take this -5/4, we're going to multiply it by our delta x. And again, a calculator is absolutely totally fine with this. And we're going to get -0.125. All right? And so we're going to take -2, and we're going to subtract, which is really we're adding, right? We're adding this number, but the number is negative, so we're going to subtract it, and we're going to get -2.125. And that's our new y value. And so we're now going to take 3.1, and let me just write, since we don't need this, so what would be in this box right here? So 3.1, which is our x, minus our y, well, our y is now -2.125, all over 2 times our new y. And so that's the value we're going to get, and then the answer to all that craziness is going to be -1.229. Again, I encourage you guys to go to at least 3 decimal places. 3 decimal places is always the best thing to do. And then we're going to take this number right here, so -1.229, and we're going to multiply that by 0.1, and we're going to get -0.1229. And our final answer is going to be this, so -1.229 minus, which again, we're adding these values together, right? I want you to understand we are taking this number and we're adding this number here, but they're both negative, so we're essentially subtracting them from one another, and we're going to get that this is going to be -2.2479. So y sub 3.2 is going to be approximately equal to -2.2479. And that, ladies and gentlemen, is our friend Euler's method. It is not the most challenging thing in the world, but it is definitely pretty tedious to do because there's a lot of places that we can make silly mistakes. So we're going to come back in the next video. We're going to do a couple more of these with you, and then we're going to talk about some Newton's law of cooling. So I'll see you guys in the next video.